Hi everyone, my name is Avek. Welcome back to another lesson. So guys, if you remember in the last lesson we discussed about scaling. And in scaling we discussed about two important things. One was vertical scaling and another one was horizontal scaling. So guys, if you remember in vertical scaling, what we were doing, we were increasing the configuration of our existing server. Let's say we only have one server with, let's say, 2 GB of RAM, 100 GB of storage. Now we are just increasing the configuration. Let's say instead of 2 GB of RAM, now maybe we are making it 10 GB of RAM. Or instead of 100 GB of SSD, we are making it 1 terabyte of SSD. So what we are doing, we are actually increasing the configuration of the server. We are making it more bigger. And what was horizontal scaling? Let's say we have only one server. Now, instead of increasing the hardware or increasing the configuration, we are just taking the same server and using it multiple times. Let's say we have server 1, server 2, server 3, and so on. So this was vertical scaling and horizontal scaling. Now, there is some interesting problem that happens. Let me first show you, then you will understand it very well. So guys, let's say you have a client, okay, and you have one server. This is fine. Now this client is actually sending a request to this server. Now the server is sending a response back to this client. Okay, this is a very simple SIP system and it is absolutely very fine, working perfectly. Okay. So for vertical scaling, it is fine because we only have one server with more memory, more space and everything like that. So for vertical scaling, it is very much fine. But let's assume now we are doing horizontal scaling. Now instead of one server, we have three servers, server 1, server 2, server 3. So guys, the important question that comes in our mind, which server client should make a request to? Like now client has this burden of choosing which server because every server has its own address. Like we studied in our first module, like every server has its own address. Now if we have three servers, that means client have to choose between three servers. Let's say we have 1000 servers, then client has to choose between 1000 server, like which exactly it should choose. And this is actually very interesting problem, and to be honest with you, client should not deal with it. Like client should not decide which server it should make a request to. Client should always go to some single source of truth, and this single source of truth should decide which server the request should go to. And that's how it happens in the real world as well, because at the end we want to make sure client is feeling comfortable. Client should not face any kind of complexity. Are you getting it? So that is the whole thing. In between client and all these servers, there is something in this thing we call as load balancer. Why we call it as load balancer is because, let's say if you have multiple users, let's say if you have million of users sending requests at the same time, now you have million of requests. Now you have to make sure all these requests are going to correct servers. Like you have actually three servers in place. Now you have to decide which server this request should go to. So basically you are balancing the request between the servers. So you are actually balancing the load. So that's why it is actually calling as load balancer. It sits between client and all these servers. What is the main goal of this load balancer? To decide which server the request should go to. So guys, in this whole lecture, our main agenda is to discuss about this load balancer. Okay. Now, important thing to understand about load balancer is that even if you increase the number of server from here, or you can decrease the number of server, will the user get any impact? No. Why? Because it's not the user or the client responsibility to choose the server. It is the responsibility of load balancer. So the complexity, whatever the hard complexity of choosing the server, we are making sure it is not decided by a client. It is actually decided by load balancer. So the complexity get reduced a lot. And that is the biggest advantage of load balancer. Now guys, another question that comes in our mind is that, okay, if we have three server, how to decide which server request should go to? Let's say request is coming, will it go to server 1, will it go to server 2 or server 3? Like how exactly it will decide? So guys, there are actually, three ways by which we can do it. The number one way is that round robin. I'll discuss all three approach. First approach is round robin. So round robin is super simple. Okay, let's take an example. Let's say you have 6 incoming requests: request 1, request 2, request 3, request 4, request 5, request 6. Okay, you have load balancer in between, and you have three servers: server 1, server 2, server 3. Okay, so what was the work of load balancer? Load balancer has to choose which server it should send request to. And what is the first method by which it choose? By round robin. Now round robin means it rotate request between server. So what exactly this means is that, let's say if request 1 is coming, the first server is server 1, so it will send it to server 1. Then another request will go to server 2. Then another request will go to server 3. Then all these servers are done, then again it will rotate. First it will go to this, then it will start rotating from start. Now another request will go to where? It will go to server 1. So the work of round robin is that it rotates all the requests between server one by one. Okay. Now there is a disadvantage of using this approach. Just think thoroughly. Okay. What is the disadvantage? So let's say you have 3 servers, server 1, server 2, server 3. Okay. There is a request 1 which is going to server 2, request 2 going to server 2, and request 3 going to server 3. So guys, let's assume currently server 1 is still processing request 1. It is not free right now. But request 3, or I will say server 3 is already fulfilled. Like it is done, it is free right now, but it is not free. But what round robin is saying, whatever request is coming now, it should only go to server 1. It can't go to server 3. We know it is idle, but still it will not go to server 3 because it works in a rotation wise manner. So this is the biggest disadvantage of round robin technique. I hope you got it. Now guys, another method by which load balancer decide which server it should pick, and that is least connection. Okay, it is very simple by name. Okay, let me explain you. Now you have 3 servers, server 1, server 2, server 3. Okay, let's say server 1 is actually right now processing 10 requests. Okay, let's say there is incoming request which is coming. Okay, there is another request coming. Now load balancer has to decide which server it should choose. Now this load balancer is also managing one more thing at the same time, and that is it is actually storing which server has how many open requests. The request which is not processed yet. Okay, so let's say server 1 has 10 open requests, server 2 has 5 open requests, and server 3 has 0 open requests. Now if this request is coming least, it means whatever server is actually having least connections right now, it will send the request to that server. So in all of these things, server 3 has 0 connection, or let's say if server 3 has even one request going on, it will still send it to server 3. Why? Because it is the least one, like it has the least number of requests which needs to be processed, but other servers are busy in processing other requests. So it is very much better than round robin. Like in round robin, it is a very straightforward algorithm. Like it is just rotating in a clockwise manner, like in a server-wise manner. But this is actually intelligent. Now in this scenario, load balancer is actually also storing the number of open requests, the request which is not processed yet, which is still in processing state. It is storing that thing and it is deciding which server it should target to. Are you getting it? So this is a very interesting technique, and at a lot of places, a lot of people use this technique. Now guys, there is another way by which load balancer decide which server it should hit. Okay, and this another approach is interesting, and that is called hash based. What exactly is this? Let's take an example. Okay, so you have, let's say, user 1, user 2, user 3, because there can be multiple users. Okay, every user has its own ID. Now all the users are sending the request to this load balancer. Like all these requests are coming and there is a load balancer in between. Now this load balancer will decide which server it should hit up to. Okay, now just assume there is a function. Okay, there is a function which we are calling as hash function. I'm not going into implementation of this function, but there is a function you can implement by yourself as well. Now this function is taking some parameters. Let's say it's taking user ID as a parameter. It's taking a URL that user is inputting as a parameter. Now, the main job of this hash function is that it will return 3 numbers. Like why 3 numbers? Because we have 3 servers. So if let's say we have 1000 server, then it can return 1000 number. Like from 1 to 1000, it could have written if we have 1000 servers. But right now we have 3 servers which is working, so it will only return up to 1 to 3. So if you put user ID or URL, for every user, the number can vary. Let's say for user 1, it can be 2. For user 2, it can be 1. For user 3, it can be 3. Now, the thing is that for user 1, if with the same user ID and the same URL, server ID or the number will always be 2, So what exactly is this mean? Let's say if 1 is there, then request is going to server 1. If 2 is there, request is going to server 2. If 3 is there, request is going to server 3. But eventually, if you see, the same user will go to same server every time. Why? Because user ID and URL, if is same, if the user is hitting the same URL, then with this hash function, we will always get number 1 and it will always go to server 1 to, fulfill the request. I hope you got it. So this is the interesting thing. Because of hash function, we can eventually, make sure the same user should go to same server if it is active. and it can help us in many ways. Now this server can remember details of this user. Okay, this is a user, it has all these things, like some in temporary storage it can store, so that next time when it lands, it knows about this user a little bit. And whatever I'm saying, like it knows about the user a little bit, that is actually calling as caching. Okay, caching, I'll come to the next modules, don't worry about it. But the whole thing of hashed based algorithm is that same user or same set of people will always land to same server. Okay, in older approaches, the same user might not come to same server every time. It all depends on, let's say in least connection, it depends on which server is free. In round robin, it depends on what was the last request goes to which server. So that is the whole thing of hashed based algorithm. Now guys, another thing that we need to discuss, and it is actually very important. If you remember, we discussed in previous lectures, and that is like why we were doing horizontal scaling. Let's say if you have 3 or 4 server, okay, and server 1 got disrupted. Let's say server 1 got disrupted, its hardware got corrupted, or electricity is not there, there is a power cut, anything can happen. Okay, now there is only 3 servers, server 1 is not even available. So guys, there is a load balancer. If a request is coming to a load balancer, then it should be aware which is the active server. It should not even send the request to the dead server at all. So therefore, there is something called health check. Okay, and the main responsibility of health check is on load balancer. In every few seconds, this load balancer make requests to all these servers, like whatever servers which is in our system. In every few seconds, this load balancer send request to all this server, and if a server is responding with, hey, I'm here, or everything is good, then it is marking, okay, server A is fine. It is sending request to server B. Okay, server B is fine. But let's say if some server is not responding to its request, then it is marking as dead server, and it will not even count that server when the new request will go to. It will not redirect that request to the server. So this is also the important advantage of this load balancer, that it keeps health checks in place. It tries to keep, okay, what is the active server in our system right now? And this is the most crucial thing in any kind of thing if you really want to scale. And let's say if server 1 got corrected, let's say engineers has fixed that server, then it will again do a health, because it do health checks in every few seconds. It will again send the request to server A, and server A will respond, hey, I'm good. Then it will mark it as, okay, this server C is good. Then everything is fine. Then everything is back on track. Now guys, there is one more thing that I really want to discuss with you, and that is sticky session. Now, what is sticky session? It is actually very important. So how exactly it is important, let me tell you. Okay, so if you remember, in the last lesson we discussed about stateless and stateful. I told you if we really want to do a horizontal scaling, we should be making sure like our whole system is stateless. That means server should not store any kind of information of a particular user, because if we have multiple servers, say if a request go to another server, the existing information of that user will get lost. Okay, so that was the thing, which I'm not denying right now. If you want to do a horizontal scaling, you have to make sure your whole system is stateless. But let's say if you are transitioning, let's say if you are already in a stateful manner, but if you are transitioning, you are not having stateless right now, you are having stateful right now. Okay, then there is a concept of sticky session. Now, what exactly sticky session is that? It actually remembers which user belong to which server. Let's say if you have 3 servers, server 1, server 2, server 3, it remembers, okay, user A will always go to server 2. User B will always go to server 3. User C will always go to server 2. What does the sticky session means? It actually remembers which server this user should go to, because in this server only the information of A is available. It is not even available in both of these servers. It is only available in this server. And this concept of sticky session is actually very temporary. Till the time you are not transitioning into stateless, you can use the sticky session approach. And the whole logic of sticky session is actually reside in load balancer only. Like load balancer has this some storage thing, or I would say cache thing, which stores a little bit of information. Okay, hey, this user belongs to this server. And it is kind of similar to hashed based. Like you can also make a function based on hashed, okay, which server is available or not. But this sticky session is a foolproof thing. Okay, you can actually map user with their own server, so that we can, temporarily deal with stateful problems, because right now we don't have stateless architecture. So temporarily we can, have stateful things. Now guys, another question is that where exactly this load balancer lives. So the first thing that I want to tell you is that the very closest thing, it lives in your DNS. Okay, let's say you have your internet. Okay, your internet will go to the DNS notebook. Okay, you are making a request to instagram.com. It is going to the DNS notebook. It is deciding which server to contact to. So we have different regions. Let's say we have US region, we have Europe region, we have India region or Asia region. Now wherever your server is nearest to you, it will only go to there. So where exactly it is living, it can live in DNS level as well. But load balancer is not restricted to DNS. It can live at any level. Like it can be present at any point of time. The whole work of load balancer is that it should decide which server should handle the incoming request. That is the whole funda. Okay. I hope you got it. So in the next lessons, we will continue our whole fundamental modules and we'll discuss more on some interesting concepts. Thank you so much. Have an amazing day.